Open channel. Open channel flow, a branch of hydraulics and fluid mechanics, is a type of liquid flow within a conduit with a free surface, known as a channel. The other type of flow within a conduit is pipe flow. These two types of flow are similar in many ways but differ in one important respect: the free surface. Open channel flow has a free surface, whereas pipe flow does not. Trapezoidal. The perimeter of the trapezoid is the sum of all the sides. P is equal to B plus 2y, the area is equal to 2b plus b times d all over 2. The formula of getting the discharge is discharge is equal to the A times C times the square root of R times S, where A is the area, C is equal to 1 over n times R to the power of 1/6, R is equal to the area over the perimeter while S is the slope. Proportions for most efficient sections is the one that have least weighted perimeter and therefore requires the least cost of grading and lining, which makes it most economical. P is equal to B plus 2y, where y is equal to the depth times secant theta. That will be equation 1. A is equal to base times depth plus 1/2 of tan theta times d times 2. So BD is equal to area minus depth squared times tan theta. So base will be area over depth minus depth times tan theta. That will be equation 2. In equation 1, substitute the base. By partial differentiation, area will be 2 secant theta minus tan theta times depth squared. Sun in equation 3, perimeter is equal to 2 secant theta minus tan theta times depth squared all over d, plus 2 secant theta minus tan theta times the depth. So perimeter will be 2 times 2 secant theta minus tan secant theta times depth. That will be equation 4. R is equal to area over perimeter, so substitute the values of the area and perimeter. R will be the half of the depth. So x is equal to base plus 2y, so x is equal to b plus 2 times the depth times tangent theta. That will be equation 5. Base will be 2 times the depth times secant theta minus 2 times the depth times tan theta. In equation 5, substitute the value of b, and x now is equal to 2y. Therefore, the most efficient trapezoidal section, including the rectangle, has its top width, x, equal to the sum of the sides, 2 years, which is a proportion for a half hexagon. So from equation 2, sin theta is equal to 1/2. Theta will be 30 degrees. So as shown in the figure, all sides are equal. Sample problem. Example. Compute the discharge capacity of a trapezoidal canal with a depth of 2.5 meters. With an average velocity of 0.9 meters per second. 1. For a most efficient section. 2. If the side slopes is 1 vertical to 2.5 horizontal and the width of the canal is 1.2 times the depth. 3. For a channel to have a minimum seepage, with sides having a slope of 1 to 1. First problem is to get the discharge of the most efficient section. Given the depth of 2.5 meters and the velocity, which is 0.9 meter per second. First to do is to draw. As you can see, d will be equal to the base times sin 60. Base is equal to 2.89. So we can get the area now. Area is equal to 3 times the base all over 2 times the depth. If we can get the area, we can get the discharge. Discharge is equal to the area times the velocity. So discharge now is equal to 9.76. Second problem is to find the discharge if width of the canal is 1.2 times the depth. So it says that the base is equal to 1.2 times the depth. Base now is equal to 3 meters. Slope is 1 over 2.5, so we can get the value of A. A is the unknown length for x. X will be 6.25. Area, to get the area, multiply x plus the base to the depth divided by 2. Area is equal to 23.125 meters squared. Same as the first problem, discharge is equal to the area multiplied to the velocity. Discharge in this problem is 20.81 meter cube per second. Last problem is to determine the discharge for minimum seepage. Since the slope is 1:1, so the theta is equal to 45 degrees, So we can get the base, which is 4 times the depth plus tangent theta divided by 2. Base now is equal to 4.14 meters. Same process getting the area of the trapezoid, and the area is 16.16 meters squared. Getting the discharge area times velocity is equal to 14.94 meter cube per second.